OpenAI just posted a job listing paying 3 times the market rate for a robotics mechanical engineer. What does this role tell us about value creation in hardware engineering, and how can we build skills that are valuable whether AI humanoids deliver on their promise or not? After spending a decade across biotech, robotics, Apple, autonomous vehicles, and meta wearables, I've learned the danger of leaving stable roles for hyped opportunities. I felt it firsthand leaving a cushy Apple role for autonomous vehicles, only to get laid off 8 months later. It's been a wild ride since then for myself and many of my peers, hopping between rocky ships in this volatile environment. Being a versatile generalist may seem more exciting than specializing in the narrow expertise afforded by most jobs. It may be the natural result of layoffs or pivoting out of roles that weren't a good fit. But every time you switch, you devalue your prior industry knowledge, reset your company internal influence, and have to adopt a new corporate culture and tech stack. The most successful engineers committed to one technical domain and became leaders in their teams and their fields. If I could do it all over again, I'd specialize. But in what field or expertise? Humanoid robotics are hot right now. Top companies and VCs are betting humanoids will be the most widely adopted household robot since the Roomba launched in 2002. My friends in robotics are excited for all the unsolved problems and innovative approaches, but they're also anxious. The technology is still years away from commercial viability. If you're nervous about specializing in robotics right now, you're not crazy. I want to share my observations of technical challenges and innovations in humanoids. From that, I'll highlight skills valuable for roboticists, but also highly transferable across consumer electronics, hardware engineering, and entrepreneurship, so we can hedge intelligently against any market volatility coming our way. Part 2. What makes skills valuable? The role is for a mechanical engineer in robotic sensing, 6+ years of consumer industrial electronics experience, 2+ years specialization in developing robot hardware with tactile and proprioception sensors like inertial measurement units, or IMUs. Why does it pay up to $460K plus stock? It's not just about sensor integration, but developing hardware systems to enable scalable robot training data collection. This is the key insight. In the age of AI, the value of hardware lies in enabling AI to learn faster, better, or cheaper. A quick history recap. OpenAI was actually one of the first AI robotics pioneers. Back in 2019, they trained neural networks to dexterously solve a Rubik's Cube one-handed. But they disbanded the team a year later in 2020, citing lack of training data. In late 2022, ChatGPT was released, trained on an internet scale of data. Now OpenAI is rebuilding the team to address this scalable data collection problem. Robotics currently lacks this internet scale of robot training data. Videos of people doing tasks are low-quality data and insufficient for training. You can't become an Olympic-level swimmer just by watching videos of Michael Phelps channeling a dolphin, because videos don't capture all the invisible forces applied to the water, the muscle impulse commands, firing away with every stroke, nor the torque applied at each joint. One type of higher quality training data comes from the demonstrations by human operators, teleoperating, or even directly moving the robot. But data collected from an operator driving a robot to generate each demonstration is often prohibitively expensive to collect at scale. Think of thousands of robots, operators, and demonstration stations running in parallel. Teleoperation also has its limits, since humans rely heavily on compression and shear force tactile feedback for dexterous tasks. But even if you add tactile sensors to robots, how do you transmit the information to a human operator? Imagine trying to teleoperate a robot to use chopsticks without the sensation of touch. Among these challenges, one stands out as particularly critical. Dexterous manipulation, the precise handling of objects in complex scenarios like piles of clothing or fragile dishes. These tasks are trivial for us, but surprisingly difficult for robots. When I first heard about this job, I got curious. I was at a Humanoid Robots conference here in Seattle and stumbled upon a booth with super high fidelity, piezo-resistive tactile sensors. I thought, could I integrate these into gloves and robot hands to collect training data? Would this be a valuable company or at least a compelling side project? I ran it by my robotics engineer buddy who shot that idea right down. Not only are there several companies like Manus already making tracking gloves, but other approaches are better for collecting training data because they solve the core problem with tracking gloves. Human-robot hand morphology differences. Human hands have an astonishing 27 degrees of freedom. Companies like Shadow Robot and Clone Robotics have developed high degree of freedom anthropomorphic hands, but every degree of freedom you implement costs money, space, weight, and controls complexity. A full fidelity 5-finger hand with 27 degrees of motion might be luxurious or wasteful when 2 or 3 fingers are enough for most tasks. So instead of giving every robot a super expensive lifelike hand that needs 20+ motors, you give it 2 or 3 fingers. But now you have a different problem. How do you teach 3-fingered robot hands using demonstrations from your human hands? Let me show you how Top Labs solved this. Stanford and Columbia University developed UMI, Universal Manipulator Interface, a low-cost open-source data collection framework. You just mount a GoPro and 2 mirrors onto simple 3D printed handheld grippers. They're just opposing jaws gear coupled to a spring-loaded trigger, and operators use them like hand tools to demonstrate picking things up, folding clothes, or doing dishes. The brilliance is in how thoughtfully simple and efficient Yumi is. A gripper with just a single degree of freedom, not 27, Yumi collects data with a single camera feed, recording the environment and fiducial markers, tracking the gripper's position. The Yumi approach is more scalable, versatile, and generalizable to novel environments and tasks. If you need more dexterity, there's another promising approach called DEXOP, a passive exoskeleton that links the human hand to passive robotic hand movements with mechanical linkages. Researchers from MIT and Berkeley developed this approach called perioperation that sensorizes and records human manipulation with maximum transferability to robots. A human operator wears passive exoskeleton hands with vision, proprioception, and tactile sensors and uses it to manipulate objects and demonstrate tasks. Training using the DEXOP approach leads to significantly better task performance compared to training with teleoperation data. Notice the pattern here. The most valuable contribution isn't building the most complex hardware, it's building hardware that enables scale. Yumi's single degree of freedom beats 27 degrees of freedom because it's more practical to deploy, collect data with, and transfer to actual robot hardware. This is a transferable insight that goes way beyond robotics. In the age of AI, one of the most valuable things you can do as a designer or hardware engineer is enable data collection at scale. We're in this AI gold rush, so many companies and startups are racing to find profitable applications of AI. Ilya Sutskever, co-founder of OpenAI, said data is the fossil fuel for AI, pointing out that AI progress is hitting a wall because we've already trained on most of the useful data available on the internet. But in any gold rush, the surest way to make money is to sell shovels. In this case, it means building the hardware that collects data useful for furthering AI. We've seen this pattern in robotics, but there's a broader opportunity. There are countless routines, tasks, and interactions in our daily lives that could be analyzed and improved by intelligent hardware. And there's lots of overlap in the skills needed to build any sensorized devices. The pace of work in humanoid robotics right now is frantic and chaotic. The technology still seems years away from being commercially viable, and economic uncertainty is growing. When the autonomous vehicles bubble popped in late 2022, companies far from revenue shut down or laid off much of their capital-intensive hardware teams. The job market was flooded with thousands of hardware engineers looking for jobs. This creates a dilemma for hardware engineers. If you're specialized in cutting-edge robotics and the market shifts, you're vulnerable. But if you're purely doing traditional mechanical engineering work, you're likely underpaid and stagnating, missing out on the most exciting developments in the field. Whether robotics and AI booms or busts, whether we see a recession or continued growth, you want skills and credibility that are transferable across high-growth roles and opportunities. Part 3. Building transferable skills. The best way to pick up skills is to learn by doing and working with a clear purpose. Hardware is multidisciplinary and expensive to prototype, so people struggle to identify a product worth building and then how to build it. The first step is to connect with smart, creative people with ideas and passion. Coming up with ideas gets easier by talking with people and hearing about their problems and solutions. Y Combinator's Startup School is a great free platform to link up with potential collaborators or people to bounce ideas off of. Next, you'll want to lower your expectations and just build for the sake of building. 97% of hardware startups fail, so understand that you're taking long shots where the expected return isn't millions of dollars, but better positioning for your next opportunity. Doing side projects has two main benefits. 1. Skill development. Working on real hardware, even simple hardware, teaches you lessons you can't get from courses, tutorials, or your day job. It pushes your creativity, resourcefulness, critical thinking, and grit in ways unique to being in the hot seat, having full responsibility. 2. Growing your network and credibility. You bring something exciting to the table as you connect with engineers, collaborators, and users. Builders respect you more for trying to build something new. Passion is infectious, and people naturally want to help those with curiosity and hustle. Collaborators who've enjoyed working with you can better vouch for you and pull you into new opportunities even if that project doesn't pan out. If you're searching for an idea with market potential, I suggest exploring health, wellness, and productivity. People are willing to pay to become better versions of themselves. Look at 8 Sleep, Whoop, Aura, and Peloton. These are billion-dollar hardware startups. Their hardware analyzes your sleep, health, or fitness data, then offers insights for a subscription. These companies succeeded because they built valuable platforms around data at scale, the same winning strategy as OpenAI. Evaluate potential projects through these lenses. Market validation. Do people actually have this problem? Talk to 10 potential users. These conversations fuel your conviction and inform design decisions. Smart hardware potential, where data or automation creates clear value. Can you measure something people care about or automate something tedious? Can you provide data-driven insights to change user behavior? Even if version 1 is purely mechanical, is there a compelling path to adding intelligence? Learning value. Will this force you to develop user research, CAD skills, rapid prototyping, sensor integration, or embedded systems expertise? Resource realistic. Can you prototype this with a few $1,000s? Can you build a version that demonstrates the core value proposition with limited resources? Let me tell you what I consider high-value generalizable skills as a hardware engineer. User research and problem validation. Talking to users, understanding their actual needs versus what they say they need, determining what they're willing to pay for a solution. This precedes detailed design. It's easy to assume needs, jump to a solution, and over-engineer the wrong thing. Rapid prototyping and iteration. The ability to quickly go from concept to working prototype. This includes sketching, CAD, 3D printing, and understanding fabrication techniques. The ability to put pen to paper and spin up CAD without analysis paralysis is critical. Development is inherently iterative, so prototype to learn, not to finalize. Sensing and data collection. This is literally what the OpenAI job is about. Understanding what sensors to use, how to integrate them, how to collect actionable data. Electronics expertise may seem out of mechanical engineering scope, but it's invaluable for excelling in consumer electronics and systems engineering. These skills translate across robotics, wearables, Internet of Things, and consumer or industrial hardware. As a bonus, understanding machine learning and AI integration points where AI can add value, what kind of data you need to collect, and how to design hardware that enables AI applications. This isn't a core skill set for mechanical engineers, but it's strategically valuable if you're thinking about product leadership or entrepreneurship. Before getting too excited about launching a hardware startup, let me share what legendary hardware hacker Bunny Huang told me.
Hardware isn't like that. It's more like running a restaurant.
Hardware is like running a restaurant. You have to source components, combine them, sell them at some margin, and offer customer service. Building hardware without VC backing means you're the business owner, chef, bookkeeper, server, and dishwasher. Manufacturing easily costs hundreds of thousands of dollars to ramp up, and it's hard to enlist engineers and designers from their six-figure jobs. But you can still benefit from exploring side projects without going all in on hardware entrepreneurship. I'm exploring hardware ideas and documenting the journey to bring you along to learn together. If you found this valuable, subscribe or join my channel for updates as I share my findings and struggles. I talk with a few viewers each week about their careers and projects. If you want to chat, there are some discounted consultation slots on my website, but honestly, the best thing you can do is to just start building. Side projects energize you, make you better at your job, and empower you to stand on your own when you need to. Let me know what you thought of this video or what excites you in the comments below. I'm rooting for you.